welcome everyone to this interesting topic done by Gopal. I would like to introduce RLIS to you first. Rotary Learning Institute set up in 2018 as a division of the foundation of the Rotary Club of Singapore. Rotary Club of Singapore, the foundation of Rotary Club of Singapore started in 1993. It's an institute of public character. The foundation is a member of the National Council of Social Services. We have two divisions, which will be the Family Service Center, and the new division which is going to start will be the Elder Care and the Caregivers Center. Rotary Learning Institute currently runs two sets of programs from the National Silver Academy and the NCSS. Currently, we are getting 80% funding for this program. And because of this COVID, during this COVID period, we are not able to run any program, but we will be resuming the program as soon as we get the release for us to start this program. Now, I would like to introduce Mr. Gopal. Gopal comes with really very good experience, 25 years of experience in IT, advisory, management consultancy. He is currently the regional director of Prowler, Cambridge registered company. His experience goes from starting with DHL. He went to IBM, Magnus Management Consultant, AspenTech, Electra. He was the managing director. ABO, he was the chief operating officer, and BMG Consulting. Now, after that, he was the SAP pre-sales director for the whole of Asia. Currently, he is the regional director of Prowler. He comes with lots of experience, and currently he is embarking on this artificial intelligence journey. With this, I would like to introduce Gopal to give his presentation.
Thanks, Jayapal. Thanks to RLIS for this opportunity as well. So I think when Jayapal is saying a lot of experience, and also let me put a caveat here, right? So yes, I've done a lot of consulting work in the ERP, supply chain, CRM areas, and done a lot of customer fronting engagements and projects and stuff like that. And prior to joining Prowler, and I'll come to a bit about Prowler, I was with SAP in the regional office as a pre-sales director. And I was dealing with big accounts like BHP, National Healthcare and all. And in that process, I stumbled upon this thing called, SAP calls it Leonardo. Is basically another word for what we refer to as AI or innovation. And I think you must have heard a lot about digital transformation and how the government is promoting it. So what does that actually mean to MNCs, SMEs and stuff like that? So last year, about 8 months ago, I became a little bit AG. I just didn't want to be out of sync of what the new technologies was like and where it's going. So I decided to try and understand what AI is all about. And I ended up joining a Cambridge HQ company in UK, and they are specialized in doing research in machine learning. Okay, so I said, if I don't throw myself in the deep end, how do I learn? And how do I help customers in their digital transformation journey? So that's how it all started 8 months ago. And since then, I spent almost a good 3 months of end of last year in Cambridge. So there's got about 115 people. 50 of them are PhD researchers. So they do a lot of work on modeling and stuff like that. And my role was to bring these technologies to Asia Pac. So 8 months down, when I'm talking to a lot of my prospects and all, I realized the difficulty I had in trying to explain artificial intelligence. And it has to be expressed in a manner where business stakeholders understand it, right? And let alone the fact that, systems like ERP and supply chain and all, they themselves comes with some level of difficulty to understand, but the maturity is there. But when it comes to AI, that I see a lack of understanding and grasping the concepts as to how to apply it. So what I intend to do here is give you level 101 understanding from a layman perspective, and then use the approach of how is it being actually used today in the business context, right? So my triggering slide here is, I'm going to just load all this up here. And all of you would have heard about Google, Netflix. You can see autonomous vehicle on the left, imaging recognition software, chatbots, if you call DBS, everything is on our bots, the gaming, the younger generation, okay, and social media. Every one of these applications actually has got AI embedded. And what you see here is a Roborock. It's my recent purchase to do vacuuming in my house, right? So it's so easy, but I was so amazed. It comes with a mobile app. It actually tells you all the dimension it has cleaned, and it gives you the map of the locations it has gone to and all. So it's really, really, this is all robots, right? So fantastic. With that algorithms that also behind these robots here. So what I'm going to do is, this is how I'm going to walk you through, right? If you go in Google or Wikipedia, what AI is, you will see tons of representation. And that was also one of the reasons why it motivated me to say, how I challenged myself in the last couple of months to bring some concepts to make it simple. And that's what I'm going to achieve here. I'm going to try my best, and feel free to give your comment at the end. Then I'm going to talk about types of AI technologies, focus a lot on the industry use cases, because the industry use cases will give you a sense of understanding, an easy way to grasp how the technology can be applied. And I will be using commercial use cases and explain to you how those deployments have been made. I'll talk a little bit about adoption trends and what next. And then we'll leave about 10 minutes for questions. So I've got about 25 minutes, and then I'll have about 10 minutes of sessions, right, on Q&A. So in terms of definition, I'm not going to read too much into this, but it was coined by John McCarthy in 1956. And he expresses it as a science and engineering of making intelligent machines, especially intelligent computer programs. I mean, that was the context in 1956. In 1959, Arthur Samuel refined it further, and he said the ability to learn without being explicitly programmed. So that concept was interesting. It was still very conceptual at the stage. I think in the 1980s, they started doing, there was two programs that they were talking about as artificial intelligence, the Prolog and Lisp. But there was not much funding into that area, and also because compute power was not strong enough to allow that. I particularly like this, what I've marked in blue here. Machine learning, okay, AI machine learning is a way of training an algorithm based on data so that it can actually adjust itself and improve data. And what actually that means is that it is like an automated programmer in a very simple sense, because we still need to do programming. But what this machine learning capabilities is, it learns from data, very different approach, and then it generates some kind of programs to address what you want to achieve from the data. And the use cases will go into that. Okay, so I'll leave that thought for now. And what are the goals of AI? Okay, to exhibit intelligent behavior, understand it, reason, learn, and then do problem solving. So I think if you look back maybe 10 years ago or 20 years ago, there was a lot of research in that area, but it was still very research based and it was not commercialized yet. Yes, they did use it for certain industries like the military and all, where there's a lot of money and a lot of spending. They have used it quite a bit, but it was not affordable for, in the business context, to proliferate this technology. And I think today we are in a situation, and I'll talk a bit about that, how the adoption is going to go a lot more faster in the next 5 to 10 years. Okay, so it's all research based, right? So I have classified some of these components, and I'll go one by one, right? So the AI is also composed of agents. And when I say agents, it's like things like sensors, cameras, imaging cameras, CCTVs, and stuff like that. Those are also, and even temperature sensors in a van that needs to keep the chocolates or ice cream at a certain temperature, and they are distributing from the distribution centers to the retailers, right? So these are all agents. So now what you can actually use is these agents, they can actually promote the ability to bring data out, and models can consume it, okay, to do some further algorithm. Heuristic has been there in the operations research world, and they used to write programs as well. They're all also programming based, but they have some kind of intelligent algorithms you write. And one of the examples is search engines and stuff like that. They also use some kind of heuristics to be able to do like a kind of a plunge, right, from the tree top. You go down to the nodes to see exactly which way to search and get your information in a very speedy manner, right, and performance as well. Then we have this thing called fuzzy logic, and fuzzy logic came up as a little bit of an advanced component to understand reasoning, because computers can only understand 1 or 0, yes or no. But then human logic is also, we have our own connotations that resembles, it's a possibly yes, possibly no, certainly yes. So there is a fuzzy logic engine that also uses to help infer. So all these tools sort of like helps build up, right? Then we have NLP, which is now, I think, there's a lot of articles on NLP using written speech, how to recognize them, how to translate them. The moment you can translate them or digitize them, they are data. Then you can start working on the next step of looking at mining the data and applying models to it. Then we also have expert systems. So expert systems have pushed a boundary. The only difference is expert systems, within the boundary walls, it has to have the knowledge base and inference engine. You must have that in place. If you have not taught the expert system, the boundaries, the yes and the no's, and also the inference, and also inference engine has got different level of capabilities and performance. And the better it is, the better the output of the expert system. Then we have something that's very commonly seen, robotics, like the one that the vacuum Roborock that I would mention to you about. They are intelligent robots, but they are already programmed to do a certain activity in a certain environment, right? They mimic some kind of real world environment, and then you actually program that to address what the outcome the robots will do. Last one, but not least, is the artificial neural networks. Okay, so you would see that machine learning is mentioned, then you will see ANN or neural networks also mentioned. Then there is concepts. When you go further, they talk about machine learning that is supervised, that is unsupervised, and reinforced. So if I were to dissect the spectrum of the technologies, you have the low touch technologies to the high touch. So the low touch could be very simple chatbots, as an example. The high touch would be in the spectrum of neural networks, machine learning, where you can actually have algorithms that has a specific understanding. For when you say supervised, it understands the relationship of a data input and a data output. But if it is unsupervised, which is very interesting, it doesn't know what to expect. It got data models, it got millions of records to crunch, and then it would recognize it, classify them, segment them, reason, and then tell you these are clusters of information that are grouped together, but you have to decide what you want to do with that, right? So the decision is still human. Then, of course, there's other algorithms that they are trying to do, is that with certain equations, you can also make a decision to say the service level that you want to give to your customers, or having, when you say you have a lot of service levels, means, let's say, take for example of NTUC Fair Price, I want to have enough stocks to be able to supply to my retailers. So they have about 280 retailers outlets, and then the 280 are serving customers like us. So I want to make sure that I have service level. But what happens to that is that you carry high inventory. So there's a trade-off, right, between high inventory versus optimal inventory. So your cash flow is also working in your favor, right? You don't leave too much cash and you have stock obsolescence. So this trade-off is what we call decision making, and I'll come to that. So that is where the frontiers of research is pushing towards, where they say businesses can use it in terms of making decisions and critical decisions. Okay, I will move on. Questions at the last. I'll get 10 minutes, and you can put it on the chat, in the chat box, right? Okay, so I'm going to start with the fact that we all have data, and data's all over, and I need to introduce a concept called the 3 V's in data. The 3 V's is basically volume. That means you've got humongous volume. Second one is velocity, how fast it comes in. So for example, if you've got a meter reader, utility meter reader, it's reading, how much consumption of air conditioning you're using. It can come fast, it can come slow, you can decide. But let's say those readers are giving you very very fast, so it's velocity. And the third one is variety. And variety means with one data, it has many attributes. And I need to understand the variety that comes along with it. So for example, if I'm selling a model of cameras, and or let's say shoes, and then I got color, size, dimensions, right? So I got a composition of a model with color and sizes. And all these are attributes that I need to deal with. And so I have variety. And then it can also expand onto maybe customer interest and the kind of purchasing behavior in a certain country. So that's what variety is. So these are three V's, right? And these three V's actually gives complexity to the problem that we want to solve, right? So one of the one that I already mentioned, chatbots, DBS, most banks do it right now. So you're very familiar with that. Then you have the Internet of Things. So these are the sensors I talked about earlier. They are agents. They read the data. They give you the raw data. And accumulate the data and park it into a cloud environment, and then you start doing machine learning on it or RPA on it and stuff like that. RPA is robotic process automation. It has been there quite a bit, and what it does is that it helps automate certain processes in the back end. It could be in finance. It could be in the HR. So there are a lot of proven technologies using RPA, right? Then you must have heard of blockchain, very popularized by Bitcoin. And blockchain is used in the process of managing ledger and traceability. So you can use that for financials. You can also use it in the context of pharmaceuticals, your base, where the materials are coming from, where the raw materials are coming from, where the manufacturer is coming from. And last but not least, machine learning, right? So, and all these technologies has a combination as well. You can use chatbots with RPA. You can use IoT with RPA and machine learning. You can also use blockchain, RPA and machine learning. So they all can converge depending on the business case, right? So without going into that kind of complexity, I leave them as an isolated technology, and I'll try to weave them across some of the business processes where you can actually bring them together, right? Okay, so what I'm going to use is I picked up 3 use cases. Happy to share another one if I have time, right? So I'm going to start with the preventive maintenance using IoT and machine learning. Another one on e-commerce, because every one of us today during the COVID, I'm sure most of us are buying things online now, especially for delivery. Food is the most common one, but there's also other home items that we are buying on e-commerce platforms. And then another one, which is cross-purpose automation. When I say cross-purpose, it's cross-industry, cross-functionalities as well, and where you can actually apply RPA and machine learning, right? Okay, the first one. So preventive maintenance. So in most companies, utilities, oil and gas, chemicals, pulp and paper and all, they will have equipments that they actually need to run in a plant, right? For a manufacturing process. It could be anything, it could be turbine, and it could be any sort of equipment that you use. And all of them today, in today's context, actually come with a system, with a backend system that actually gives you data now. So they're all digitized. Most new, semiconductors and all these industries have equipments that actually produce data, right? They call them DCS or SCADA. And those data is right now residing in the machine, and they give them a dashboard and says, okay, what is the performance of the machine, usage information, historical measurements and all. These data are very valuable. And 10 years ago, you never heard of this concept of IoT or digital twin, where you can use machine learning to make certain decisions or do preventive maintenance on. Today, this is becoming a norm because the equipment manufacturers like Yokogawa, Honeywell, they are actually providing machines already with data. And they say that they also can provide machine learning. So interestingly, the machine guys are also propagating that they also have machine learning algorithms, right? But the point is that they can get those data, they can put it onto a cloud, and they can actually mine those data. So in this context here, I'm getting information about my performance on my machine, the usage information, past usage information, like how many hours it has run. It gives you historical measurements. It also tells you breakdowns and all. What was the past breakdowns and all? What machine learning does is it reads those data of past. So let's say if you have this data in the machine, or you store them in ERP systems under plant maintenance, could be SAP, Oracle, or Microsoft. You keep this information there. You can actually read all this data on past history of breakdowns of certain turbines, certain models of turbine, okay, and it can classify all this in the. So the machine learning, what it does is it will understand, read, and it will give you some kind of prediction. But the first prediction it does is that, let's say it got heat sensors and it goes beyond a certain temperature, or vibration sensors, right? So what it does is immediately it triggers an alert to the maintenance team. It could be an internal maintenance team or an external maintenance team. So what they do is they get alerted to this machine. They will know exactly where the location is. You can use GPS mapping and stuff like that. Today's all very available. They know exactly the serial number of that equipment. They know exactly what is the past breakdown, so they get the historical information. They can have it on their mobile. Nowadays you can actually carry mobile devices as well. Have everything, and then you go straight to address it. You do the work execution, and you do the result sharing. It could be that it was a very minor, but the information is triggered to say for you to react, and then you can actually record it as exactly what happened in terms of your when you actually do your analysis. The analysis data will be captured, and you will go back into the machine learning model, which sits on the cloud here. It remembers this, so it says that for this particular incident, this has happened. And what the model does is the model learns and trains the model to get more perfect, more accurate. So as time goes on, the model becomes intelligent to read and understand, and it will keep this data. So the next time a similar case happens, it will make a decision to say, yes, I think I need to alert it, or no, I think I don't have to alert it. And this is where I'm going to introduce the concept of confidence level. So a lot of the models have also this, they embed confidence level. This confidence level gives you the feeling based on historical trend and the model learning capabilities to say, I think there's a 80% chance that this machine is going to break down. Then the guys who are planning and the plant maintenance guys can decide, okay, I need to actually execute something quickly because it's 80% chances. But let's say if the reading comes with a 50% chance, then they can actually take a call. And in companies like oil and gas companies, right? Turbine going down means you lose a lot of money. Why? Once one part of the turbine goes down, the whole manufacturing line is stopped for a couple of weeks because they need to actually disassemble it, put it back to do tests, make sure it works and all, and then continue manufacturing. So 2-3 weeks of lost time is a lot of money. So the model actually learns and propagates this. And additionally, what it does is it also propagates information that is relevant to the manufacturer. So nowadays, even manufacturers wants to know, and they want to also be able to see the performance on their own machine. So a lot of manufacturers are now offering this service. So they say that I got the equipment, I got the sensors, I can put it on the cloud. I can also read information for you how to react. But the missing puzzle is that the maintenance people here are usually internal team or outsourced, and that is too far away from the manufacturer. So this use case here has got a lot of legs, and a lot of the oil companies that I'm familiar with in Middle East and Europe and Shell and all are using it. And they actually take the 80-20 rule. They actually put sensors. I think most equipments have sensors, but some equipments are very expensive, like turbines, they go into the hundreds of thousands, so they cannot afford it to fail. So they can decide which one they can actually apply machine learning models to, right? The second one is a favorite of mine because I've done a lot of implementations for e-commerce companies and backend ERP. So a lot of us have actually probably gone into Lazada, Zalora, Amazon, and all, and we have bought things. So as you can see, there's a lot of information, and all this goes into a data. So most of the companies, of course, the Alibabas of the world, the Amazons of the world and all, they have got deep pockets. They got plenty of researchers doing work on the data that they get. So I was told that in Shenzhen, Alibaba has got about 10,000 programmers. Of course, they do a lot of stuff, right? I'm not sure what the team that just does research on modeling. So what they do is, it is kept on the cloud as well. I mean, I've just isolated it right now. But what they do is they do a lot of data mining using machine learning algorithms to serve many, many purposes, right? So in the e-commerce platform, data is humongous, right? Maybe one day you can easily get 1 million to 2 million transactions, actual transactions, right? Not transactions that actually ended up with a sale. There are others, maybe another 2-3 million, who just actually go and browse, which I also do. I browse certain prices and all to just see what's my interest, what's the price like. And even those are mine. So they actually can understand from the IP address what kind of people came in. They just browse, how long do they stay? And on their website, they can actually analyze all those information. But there's millions of transactions to analyze. So you need the power of a data lake to help you. And then machine learning. Okay. And what happens with the machine learning is it gives you certain dashboards because you are looking for specific items, specific things. And what you see here, this man here is going 4 ways is actually decision making. Which way to go? Which way? What decisions do I have to take? So the whole sequence is in transactions happening on the platform, data is gathered, the data is extracted onto a machine learning algorithm model on the cloud, and then giving you some insights. So let's talk about some of the insights. What are some of the potential insights? So these are real use cases that's being used by all the big guys in the e-commerce platform. So first one is customer segmentation. So profile by gender, age, location, and stuff like that. So there's many variables, right? This is what I talked about variety. A customer that I want to profile. I can also group the customer according to a certain age group and all and profile them. When I segment by a certain criteria to understand purchase behavior, type of products, models, basket value, time of purchase. So you know that the youngsters will probably do their purchase probably in the night, right? So they actually, and most of the times when you purchase, you give your details and data, right? Some extent they have more data and some they might not. But based on the type of purchases, products you buy, they can actually segment you. They will classify you into a certain group, right? Male, female is easy, but first thing is propensity to buy, and how long you spend before you buy, what is your purchase behavior, what is a social media platform and stuff like that. So once you can actually segment your customer base into a logical sequence, and that logical sequence must make business sense to your company. Means it must make a logical sense to say, from a revenue standpoint or cost standpoint, to say, I will make certain decisions for this target group who's buying it. So for example, giving promotions, marketing promotions to similar type of products or correlated products, right? They recognize that you have actually searched that product before. And let's say you didn't buy, and they have the intelligence to even promote other similar type of products to you while you're still browsing their website. They gather insights also when you post something on social media, good or bad. All this is taken into consideration. Another one is also complaints management. So if you have actually a lot of complaints management, they also address that. So you can have insights to address it. In today's context, customer is king. So reading customer signals is primary. And every business, whether it's B2B and stuff like that, they are, becoming, and B2C, they're becoming very customer centric. Then you have the pricing strategy. So what can you do with pricing? So an example would be, there's a kind of product that is being sold. Say, let's say mask of a certain, during the COVID, certain mask has got certain popularity because of write-ups and all, and they're selling very fast. What this e-commerce platform guys can do is, based on stock levels that they have, stock cover that they have, they can actually decide, because this is a high seller item, I can put 10% notch point up and I can clear my stocks and I can come up with the next, or I'm going to get the next batch coming in at which period of time, I know it will be sell, I can make 10% profit on top of the price that I'm selling at. So pricing strategy, and they call it dynamic pricing, is also available. And of course, other insights like customer returns. And customer returns has a big impact to your revenue, or more so costs, right? Because you don't want to lose the customer and you have to know the nature of the complaint. And secondly is, there are behaviors there where customers just want to test the product and then return it as well. And that's very common in the UK and US from what I hear. So e-commerce platform have to also understand those kind of behavior and decide, how do I react to those kind of the customer returns as well? Because there's a lot of money, right? So with that, I want to spend a little bit more time on, I'm coming back to the machine learning part here, okay? There's a lot of things that happens inside. I went through very fast at a very high level, very layman explanation. But in here, what does actually these models do? So these models have a couple of ingredients, right? One of them is being able to give you a probabilistic forecast, a number, but it has to give you the confidence level. And this confidence level is important in today's context, right? In the past, we have also statistical algorithms. You're familiar with the weighted average, boosting, or auto regression. So we have those kind of algorithms there, but the only difference is it's got a black box. It does not have the ability to explain, one, which attributes is causing you to give you this curve, for example, right? Let's say take this black curve. Secondly, is it will not be able to, it can give you some level of confidence, but this confidence level is very deterministic. It's basically what on historical data. Where machine learning differs is, like I said earlier in my opening slide, machine learning is a kind of way to program based on data. Based on the data, types of data you're coming, selling data, customer profile of the data, the products is being sold and all, you can start saying, okay, I think these are the high seller items. I want to know also that clear seller items. Clear means you are 90%, 100% sure this product will sell at this period of time. But then there are other products that has got very skewed. They are very sparse. They're skewed. You don't have that kind of predictions from a human mind to be able to predict. And that's where machine learning models gives you the confidence level. And the confidence levels tell you basically you've got 80% confidence or you got 20% confidence. Why 20% confidence? It tells you because the data, the data that he has collected has got certain labels, and it says that this is very, very sparse. It's got irregular behavior. I'm not too sure. I don't think my algorithm is smart enough to tell me the confidence level, and I put it at 20%. Then humans can actually make a decision. What do I do with it, right? Comes the next point. Okay, with the model being able to crunch data and come up with patterns and segmentation, then the next thing is, can the models also help with decision making? Yes, there are models out there in research world. They are the Bayesian optimization is one of them. So it's a kind of a tool that allows you to put in, basically saying that what are your key parameters? Is it revenue? Is it cost? Is it profitability? Or is it, I want a market share in a certain region? So you can then decide based on the probabilistic modeling and the decision-making engine to make a decision. And this is key. And today, most researchers are going to the area of decision-making now. And if you go on Google, and this is the area where they're saying how machine learning can be more smarter and intelligent to be able to give the decision-making. But I take a step back. One of the biggest problem is data. And data, and I introduce the 3 V's again: volume, velocity, and variety. And that can actually have a propagation of maybe 2 million records on the e-commerce platform a day. But the variety of products, the size, the color, the dimension, the models will propagate to easily 20, 30 million kind of records I need to mine. And that's where machine learning has that power to also be intelligent enough to say which attributes matters, right? I'm just looking at time check. Okay, I don't have much time right now. I'm going to go through quickly on robotic process automation. It has been there. It has been used in conjunction with machine learning. The more popular one that I like to talk about is that a customer was trying to do compliance on financials. So they have like 100,000 invoices, vendor invoices a month, 100,000 from many vendors, 1,000 over vendors. So what they wanted to do was be able to extract information from the invoice. Sometimes they are in PDF. You need to have imaging, take it out, and actually look at vendor rating from many perspectives. First is vendor rating on the pricing and the kind of things that they buy. And you need to do this very fast. But actually, most importantly, what they're trying to do from compliance is looking at the vendor and the price historical trends and how much has it inched up. If it goes more than 20%, it will call for room for some kind of compliance discussion. On audit will pick it up. Secondly, is vendors that never actually provided this support, this services or products suddenly coming up with a service for another product is an anomaly, not normal. So actually what the machine learning can do is that as it's learning this data, it can actually pick up and say, no, I need to put this under audit, and it can actually park it for audit trails and stuff like that. So, and you can read it, and basically RPA are used in a lot of contexts, managing data from disparate system, from the internet, unstructured data, It can gather all this information and do complaint processing. It can suggest ideas to you, your service level up and stuff like that. So I think the financial institution and insurance use it quite a bit. Shared services use it quite a bit as well, right? I think I am going to just spend another couple minutes just to finish off. Very important point is data is enable decision-making process. So it's data-driven. In the past, we used to write programs and then say what the data in and out, right? And you can take data from inside or outside. It has to be digestible and user-friendly. Secondly, it has to give you the ability to do scenario planning. And this is where the decision-making also comes in. The scenario planning to say what opportunities or what decisions and what's your trade-off, right? A financial trade-off as well. If I do this, what is the impact? Last but not least is the authority to make critical decisions in a timely manner. You need this trust, and this takes a lot of effort from companies to transform. And when you talk about the real deep digital transformation journey, this is one of it, right? These tools will never work without the authority as well. But of course, you just don't leave the authority to the person to make a decision. There's a process where you need to put in place that is compliant, and then the tools give you the suggestions and you make the recommended decisions, and that can become an SOP. And the SOP can be refined as the model becomes intelligent, right? Adoption trends. And actually, you can go on Google. Most of the big players in the market actually have already started their own digital innovation. And most of the digital innovation is a combination of what I talked about in terms of AI technology. We refer to as ERP and supply chain and CRM is the things of the past. And today, it's all really driven by AI technologies. And the AI technologies also has to bring at a certain cost. And today, in today's context, we are going to get more propagation of AI because compute power on the cloud has become a lot more cheaper. So you can actually run those models on the cloud a lot more cheaper. You can actually buy models off the cloud from the hyperscalers and run a model that makes sense to you as well. Okay, so this you can Google because and the local players are doing it in different forms as well in terms of what their innovation strategy is. And last slide is talking a little bit about challenges, right? So what I'm going to say here is that deployment, there's a misconception. It's not a plug and play. We also must understand the business context and how does this come into play together with the current business processes with a human element. And because of the fact that it's intelligent, you must be also think differently from the traditional top-down approach to some extent. Change management important because, as in seen in the COVID's case, there's a lot of fear about work and obsolescence and stuff. Threat to privacy, I think you read it a lot in the papers, PDPA and stuff like that. So how many people are willing to give so much data? Threat to human dignity, well, I think it depends in few industries a lot more. I think very apparent. And I think certain disciplines probably will find it hard to accept, right? I think if you go to the judges and say you can make an intelligent machine make a better judgment call in the courts, I think that would be tough. Threat to safety, I think that is an easy one to understand in terms of how you can deploy this technology that can affect safety as well, right? Okay, I will now open it for questions, and I need to be able to see the post for questions. Hang on a sec, let me see the chats. Okay. Let me see. This is always the tough part because I got to look through. Okay, first, artificial intelligence, machine learning, deep learning. What is the difference and overlap? Where is deep learning typically applied? Okay, so good question. I think when you talk about machine learning, and machine learning has got some that are very easy models, which we will not consider deep learning. Deep learning goes into those algorithms like Gaussian process, Bayesian optimization, where they actually not only learn, but they also can come up with certain decisions between a certain framework. And in today, that's where what deep learning is all about. Another one is neural networks, right? Autonomous vehicle. That's a tough one. Autonomous vehicle, the whole concept, that Elon Musk is trying to promote actually has got more variables to deal with, and it's more complex because if you want to look at a bicycle, and bicycle on the side of the car and a bicycle at the back of a car has different connotations. So your program has to be so intelligent to be able to differentiate between a bicycle, make an image, hey, this is not on the side, this is on the back of the car, it's probably mounted. So disregard that bicycle, just look at it as a car, and so that goes a lot more deeper, right? Question 5G. 5G is going to make a big impact on IoT and adoption. Very, very true, because I think 5G, when it's there, it brings compute power to your mobile app. So you're going to see a lot more in gaming world and stuff like that. Cyber threats on the rise globally. What is your view of AI ML? Well, my company we don't specialize in threats, but I know of companies out there in the market that are doing threat detection, right? And in that they find it a bit more challenging. Why? Because you are actually not only fighting with bots, but you're also fighting with smart humans who are always ahead of the curve with new threats, and that is a tough one. And I personally don't specialize on that area, but I've read about those areas in terms of threat. Okay, I think in terms of emotional health issues, I think in terms of health, there's so much opportunities in the healthcare. You can go on Google on Siemens. They actually use, and of course, it is like the whole confidence level concept where the result is in the safe zone to make a decision. So they can read on those things that are more proven in the market. So I think the healthcare industry is looking at those equipments as well. Which one gives you that kind of confidence that I can apply machine learning to, right? So healthcare would have quite a bit of that. Okay, feedback on AI to unable to detect human emotions. Yeah, I think the human emotions part is a tough one. And I think, and that applies to autonomous vehicle as well, right? Okay, how do you see retail sector adopting some of these concepts? Any examples? Okay, I will be very honest with you. In terms of companies that are adopting such technologies, it's usually the big companies, the larger companies, and the MNCs, right? Because not all of them even understand digital transformation or innovation. That's one. So the government is trying to promote that. There's a lot of things down there, but I think it has to be brought down to a level where it's understandable, it's chewable for a customer or a company, whether it's a hawker, a shop level, exactly what it means to them. And they need a lot of help. They need a lot of where the government probably need to chip in to bring in some thought process there, right? I think that's very critical. Pros and cons. I think that's a use case that we always do, and the use cases that I had earlier shown, I actually showed about the pros and cons. I mean, more the benefits case. I think they will address the cons as part of a project. There will always be challenging matters, especially when it comes to human beings. And I think this has to be taken with a very open mind, and the culture has to be ready for that to accept as well. Which vendor's AI ML certification is most useful? Okay, I really can't comment on that. There's quite a lot out there. I know the Singapore government has also sanctioned one or two. I don't really want to say anything in that particular area. It's good to get any one of those, but there's also programs overseas that have got very good AI certification programs to understand level 1 at least. Yeah. Okay, I don't know whether I've missed anyone else. Anyone new message? In China, cafeteria is deploying AI ML computer vision to automate. Yes, computer vision imaging, checkout, even payment via facial recognition. Yeah, I think this is more on the propensity to adopt and being open about accepting facial recognition and all. I'm not really sure about how the netizens accepts that. There's always this concern. So even the contact tracing app that's got a PDPA challenges as well. Okay, I'm going to share the screen because there's some things that is required. I will just okay. I pass it to Mary now for.
Hi, good afternoon, everybody. I'm Marie Leong, the manager for the Rotary Learning Institute. Thank you, Gopal, for giving the insightful talk. I think I have learned quite a bit on AI. Thank you to everyone for attending this talk, for spending this afternoon with us. I hope you have benefited from this talk. On the screen, there are some of these courses we are offering for seniors. They are actually sponsored funded by the National Server Academy for Seniors. Gopal, can I have the next slide? Okay, we offer two range of courses. There's one is for the seniors in the community, and the other one is the courses for the non-profit organizations. So you can actually take the QR code of this and check up on our website. And what is coming up? We are going to offer short online courses for everyone. So please go to our website and check it out. They are very affordable. Do support us. And we will also be coming up with more online courses. We'll keep you updated. Do sign up and support us. Okay, next slide. Yeah. And for those those of you who would like to support the charitable cause of the Foundation of Rotary Club Singapore, you may also scan this QR code and give a donation. Thank you so much. And with this, we will end the talk.